Okay, so this is 10.6, and we're looking at the mole math practice page. So starting off with number 8 on the sheet, what's the mass in grams of 6.022 times 10 to the 23rd atoms of copper? Well, we're going from atoms to grams, so we know we got to go through moles. There's just one little tricky bit here. It's not really tricky, it's just mean. 6 times, so we put our given in, 6.022 times 10 to the 23rd atoms of copper, and we want atoms of copper, and we want moles of copper, and we want moles of copper, and we want grams of copper. So we know that this is always going to be 1. Atoms is always going to be 6.022 times 10 to the 23rd. And where does our molar mass come from? This number up here comes from periodic table, and we use 63.55 grams. Now, a few astute among you noticed, hey, that whole thing cancels that whole thing. Yeah, of course it does. That's because that's 1 mole of copper atoms. So 6.022 times 10 to the 23rd atoms is 1 mole. So yeah, you could have skipped a step on that. Does that make sense? Okay. So let's do number 10 together. I'm going to flip past this. Number 10. How many atoms are present in 25.3 grams of magnesium is how many atoms of magnesium? So we start with our given, as always, 25.3 grams of magnesium. We know we want grams of magnesium here to cancel, and we're going from grams to atoms, so we have to go through moles, always and forever. So we know this is going to be moles of magnesium. We know down here we'll need moles of magnesium to cancel. We want to end up in atoms of magnesium. So we know that this always gets a 1, that always gets a 1, this always gets 6.022 times 10 to the 23rd. Where do we get this number? Periodic table, that's its molar mass. So 24.31 grams of magnesium and 1 mole of magnesium. When we do all of our math, we get a raw answer. We get a raw answer of 6.26723918 times 10 to the 23rd atoms of magnesium. And how many sig figs can we have? 3, based on this. So we get 6.27 times 10 to the 23rd atoms of magnesium. So if you look at that, you realize pretty quickly, and you would realize comparing these two numbers, oh, that's just a little bit over 1 mole. That's just a little bit more than 1 mole. Make sense? If you didn't get that, do you see, was there a problem in your setup? Yeah, oder nicht? Problem in your setup? Okay. What were the most common problems people saw in their setups on this? If anybody's willing to share which hole you stepped into. Oh, okay. Okay. Yeah, if you make sure that the units all cancel, then that goes a long way. Okay, other questions? So, okay. We also want to do... Okay, so we start off with our given, as always, 9.9 times 10 to the 25th. Oops. Atoms of uranium. And so we want atoms of uranium down here to cancel. We're going from atoms to grams, so we have to go through moles. Moles of uranium. We know this will have to be moles of uranium to cancel, and this will be grams of uranium. So we always have a 1 with the moles. We always have 6.022 times 10 to the 23rd with atoms. Grams of uranium comes from where? Periodic table. And the molar mass of uranium is 238.03. So we end up with a raw number that is 391.3968, a bunch more stuff, times 10 to the second grams of uranium. But we have to either take that out of scientific notation altogether or fix the scientific notation. So to the fourth is, or to the second is there, bringing it back. We can write this as 3.9 times 10 to the fourth grams of uranium. It's also perfectly acceptable to write, let's see, that would be 30. Okay, so either of these is acceptable with our raw number. Okay, let's go to the next one. Okay, so we've got our setup. Our raw answer was 0.8801, etc., times 10 to the negative second. So when you fix it all up, you end up with 8.8 times 10 to the negative third moles of cobalt. Any more questions on that one? Okay, if you missed that, do you see what your mistake was? Did anybody try to make that a 3-step out of a 2-step? That's really common. You got to watch yourself. You got to watch what the question's actually asking for. Okay, let's do number 18. How many atoms are present in 5.125 times 10 to the 21st grams of calcium? How many atoms? So, GMA, we're going from grams to atoms. We got to go through moles. 5.125 times 10 to the 21st grams of calcium. We know we have grams of calcium here. We know we have moles of calcium there. We know we have moles of calcium here. We know we have atoms of calcium there. We know that mole always gets a 1. Stick those in before we can do anything stupid. Atoms gets a 6.022 times 10 to the 23rd molar mass of calcium. Good heavens, we've used that one a lot in the last few days. 40.08. Okay, the raw answer that we get is 0.770028, etc. And it's times 10 to the 21 plus 23, which might be someplace people screwed up. So that's to the 44th, 10 to the 44th. So when we fix up the scientific notation, remember we have 4 sig figs here. We get 7.700 times 10 to the 43rd atoms of calcium. That's a lot of atoms of calcium. It's a ridiculous number of atoms of calcium. It's a ridiculous number of grams of calcium. Outrageous. Completely outrageous. Okay. If you missed stuff, do you see what you missed? Do you know why you missed it? Okay. Ready to take a FIP? Wunderbar. Fip, fip, fip. On this one, you can use your agenda periodic table. If you don't have an agenda, I can give you one of the ones that you'll get from me eventually, but there's a bunch of stuff on it that you won't know what it means just yet. That's fine, just use the front. So we are missing... Go that way. Okay, I'm done. Okay. Do you need a periodic table? Just. Somebody else on the periodic table? No? Okay. Today is the 6th. 10-6-14.